the hologram. This is something that he gave me a little synopsis, and I said, this is mighty boring. But he said he'd juice it up and make it a little interesting. This is something that we're going to study metaphysics, philosophy, and what life is all about in the future. We need to know about the hologram. And so, Gene, I'm looking forward. I've bugged you a little bit of time or two, but looking forward to you getting up here and getting out of the box.
Getting out of the box, yeah.
Getting out of your comfort zone. Tell us what you know about you.
Yeah. Okay. Well, thanks, Calvin. Yeah, this I usually like to sit in the back and listen. So this is a little bit out of the box for me. But the thing about it is, and Ann thankfully brought a prop for me today, this little book. But there's a lot of stuff. Thank you, man. But, you know, there's a lot of stuff. I read all of this stuff about holograms, you know, the Holographic Universe. And this is a book that Ann brought today. It's called Stalking the Wild Pendulum, and it's about the Holographic Universe. And Greg Braden and Lynn McTaggart and a lot of the different writers today talk about the Holographic Universe. And you kind of look at that and go, how does that relate to this thing on my credit card? You know? You know? So it's something that's always fascinated me, and you know, going way back to when I was in college, because when I was in college, I studied fine arts, and at the same time, for some reason, I studied physics and science, and so I was taking classes on relativity and physics of sound and all of that, and then going to a life drawing class. So in any event, somehow or another, in later years, all of that kind of coalesced and it started coming together. So I thought I would just try and give you a little bit of basis. Some of what I did in college as well, I got exposed to holography. You know, we had in the physics department, there was a hologram set up to make holograms. And I thought that was fascinating. And ultimately, I wanted to know kind of what that was about. And at the same time that I was going through all of this stuff, there I was up in Bellingham, Washington, you know, out on the left coast, as they say. But I was in school there, and at the same time I was going to a little church called the Church of Psychic Research. And if you think that sounds like some strange things went on there, if you're not used to that kind of stuff, and a lot of folks here are exposed to you know, supernatural and paranormal kinds of things, but you know, at that point, going to a relativity class and then going to the Church of Psychic Research really kind of tweaked my notion of what reality was. You know, I just kind of, and so I started trying to put all of that stuff together. So one of the things, and I'll just kind of start out with this little diagram. One of the things that came out of the relativity class that I thought was really kind of interesting. This is one of the things that just kind of tweaked my imagination, but it was a little diagram that they call a time-space diagram, which is like a graph. You know, this is time, this is space, and they use this to plot out a particle or an object's path through time and space, the fourth dimension. You know, and the interesting thing about that is you know, there's a kind of a barrier that's built into our ability to know what's going on in this whole space here, and that's the speed of light. Because in the world that we know, nothing can go faster than the speed of light. A particle, it takes an infinite amount of energy to accelerate a particle to go faster than the speed of light, so it can't do it. And if you plot that speed out on this graph, it comes out as kind of a 45-degree angle. Let me get this so you can see. It comes out as kind of a 45-degree angle through here. And that's 186,000 miles per second. And this becomes our world. And this becomes something they call the elsewhere. What a nice term, huh?
Oh, the elsewhere.
Yeah, elsewhere. So this stuff we can know about, but this stuff, generally speaking, is a little bit harder to know something about, okay? And of course, and this is going to be, this is a review for everybody, but I just lay all this out just so we can kind of set it up. The way we describe our experiences in this world, of course, are through our senses, you know, which are sight, we know these real well, sound, you know, touch, taste, let me spell it right, and smell. And as it turns out, you know, all of these things that we're using to determine what's going on in here are really kind of limited, and we know that. You know, smell, well, we know that's limited, you know, to what's in the air and what's in our immediate proximity. Taste, well, we're limited to what we're willing to put in our mouths, or that, you know. And so the big ones that we use a lot of are sight, sound, and touch. And you know, the limits of this, and again, I know we're reviewing a lot of this stuff, but we just go step through it. You know, our ears, you know, we're sensitive to sound pressure waves in the air. You know, we know that waves kind of propagate themselves, or energy in this sense. The pressure propagates itself in waves. We know, you know, this, and there's a lot of stuff here. Let me just say, there's probably a lot of stuff here I'll just have to shortcut and just say, you know, because we kind of know what's going on with all that. But we know that it propagates itself as waves, and that those waves, you know, they're described those waves in terms of frequencies, and from here to here, from peak to peak, is called a cycle, and that's you know, and in a second there may be one or there may be more, and as that frequency increases, you know, the pitch goes up. You know, we're all pretty aware of that. As another thing, as this wave gets higher, it gets louder. So this is amplitude and this is frequency. Okay. So, but we know that our hearing is limited to about 30 cycles per second on the low end. I can play a nice low sound here. Can you hear that? That's a pretty low sound, you know. And then on the high end, we're about 17,000 of those. As we get older, we kind of lose some of that. You know, my niece and nephew, my teenage niece and nephew, have a ringtone that's somewhere up there that old people can't hear. You know, they can sit in class and their phone will ring, and the teacher never knows. And if they don't have to silence their cell phone. Dogs, yeah, dogs, and other animals, yeah, are sensitive to different frequencies. Now, an interesting thing about this, and I'll just tell you briefly, we can't hear kind of above that level, but that doesn't mean that we can't know something about that things that are of a higher frequency don't have some impact on what we're hearing. Okay? But we can't hear it directly. So anyway, that's the limits of our sound. Sight, we know that too. And as these wavelengths get longer, you know, well, let's say we're going from longer to shorter wavelengths here. And some of these long wavelengths down here, and this is electromagnetic radiation we call light. But basically it's electromagnetic radiation. But on the lower end, you know, some of those frequencies can be as long as like a tall building or something like that. But down here, these are called radio waves. The next group in there is going to be microwaves. Microwaves. Then there's going to be infrared. Then there's going to be visible light. Then there's going to be ultraviolet, UV. Then there's going to be X-rays. And then there's going to be cosmic rays. And so out of all of that, the part of this that we generally have with just our normal senses have access to, or we know these red, orange, yellow, green, blue, violet, you know. And if we want to start tweaking our notion of reality, all we really have to start doing is looking at this and saying, okay, this is the little section here that we have access to, generally speaking. We have devices, you know, that help us know that yes, these other things do exist. But if our eyes, you know, our sensors, the little filters that we're judging all of this from, were sensitive, just think about this, down into the infrared, what would we see? You know, it would be very interesting because if somebody wanted to hide in the closet, they really couldn't, because we would see the heat coming out of the closet, and somebody would walk in the room and say, why are you standing in the closet? What are you doing? You know? Likewise, if our eyes were sensitive a little bit further up this way, okay, into the x-rays, well, we've been to the doctor, we've seen x-rays, we kind of know what we would see if we were, you know, if our eyes were sensitive into x-rays, and we could go around and we could diagnose each other's cavities. You know, oh, when did you break your arm? Oh, I'm sorry to see that. You know, so anyway, there's that limitation. Now, we get into touch, and we know that touch is kind of related. You know, that's when we start getting into stuff. You know, that's kind of the stuff of our material world. You know. And so, if we want to know what's going on with that, well, we know we have compounds. O-U-N-D-S-G, compounds. We know that means wood's a compound. This is a compound. Everything. There's compounds. There's elements. There's molecules. There's atoms below that, and then there's subatomic particles. And then there's the subatomic particles. And so the interesting thing about that, and we know this, you know, is that when they really start looking at the subatomic particles, they realize, well, there's kind of not anything there either. You know, when you really start looking for the stuff, there's a lot more space in the world than there is stuff. And one of the interesting things is that whenever they start looking at the particles, the way that they can best describe those particles is as wave packets of energy. So we have energy, and everything seems to come back down to energy. And that energy gets described as little wave packets, and they look something like that. One of the interesting things that happened with me when I started to understand this, I'm in the video business, and so one of the things that we do in the video world is whenever we're putting together a master tape, you know, when we've got our program on tape now, we put some business, what we call just some business, on the front of the tape, which is colored bars and a grayscale bar, and we put a tone, boop, that runs something like sounds something. No, not like that one. Sounds something like that, you know, that we put on the head, and it's just a constant level, and it's so that somebody in, say, Chicago can know if they're going to broadcast a program, or if they're going to make a dub of something, they kind of know what the picture and what the sound was that we intended, because we put this little bit of bars and tone on the front of the tape, and it runs for a minute usually, so that somebody's got time to tweak their little knobs. And one day I was sitting in the edit suite, and we were laying down bars and tone, and just kind of sitting away from the bars and tone to lay down. And for some reason I was kind of rocking back and forth. And as I would rock back and forth, that tone would go, ooh, ooh. And I thought, kind of odd. So I thought, oh, something's, the tone where we've got our levels set wrong. So I go up and I look at the levels. No, everything's just rock solid. It's right there. You know, listen to this speaker, sounds pretty good. Listen to this speaker, sounds pretty good. Stand in the middle, sounds pretty even. Walk back and forth, it goes. Ooh, ooh. And I thought, now that's really kind of strange. So, you know, went on about what we were doing in our business. And later I was thinking about that. I thought, what was that deal? You know, what was the deal with all of that? And I started getting this picture. You know, I started thinking about how waves interact with each other. You know, and I started getting this picture. And so we know how that works. We know that if this is a tone, and this is a sine wave, this is the simplest, most pure form of a sound that we can. There are other kinds of waves, but this is a sine wave, and it kind of sounds like. That's kind of a sine wave kind of sound. There are other waves that, you know, those are all the same note, but there's a different shaped wave that's going on there. But as far as this tone, now we know how these waves interact, you know, and so if we've got this wave here, and if we run something totally out of phase with that, what we call out of phase, where now these peaks and valleys are just opposite of each other, then if you play that sound, if you play two sounds together from that, the thing that you get is nothing. You get nothing because those two sounds cancel each other out, and that's the principle behind those noise canceling headphones that you buy and that you wear on the airplane, because you know it runs a sound in there, and it's a sound that counteracts the sound of the airplane, and so it brings the level of the noise down. You don't hear it, and it actually is physically cutting down on that energy that comes into your ears. So we know how that works. Well, an interesting thing about it is that you know, if something's only slightly out of phase now, and what I figured out was happening in the room here was that we've got the wall. And the sound, let's see if I can get on this side. The sound comes up, it hits the wall, and it bounces off the wall, and it goes back into the room. And so in places, now that it's kind of a little bit out of phase with itself, in some places there are going to be dead spots, and there are going to be spots that are a little bit louder. So what's happening is with that just a little bit out of phase now, it's not totally out of phase, but with it a little bit out of phase, you know, it's going to do this. And the interesting thing is, if I wanted to plot that out, you know, if I wanted to draw a picture of what that was going to look like, it would look something like this. Which looked to me amazingly similar to that right there. You know? And all of a sudden, you know, I made that connection, like, oh. And when I realized, okay, this principle right here is a holographic principle. What it is, this pattern here, the thing that happens here, this is a difference tone. It's the difference between this tone and this tone. And that's what comes out. And if you saw that as a pattern in the room, you know, you know, you could have sound. There are actually sound objects there in the room, and they would be, you know, that's a hologram. That's a holographic effect. So that's the basic thing of what a holographic effect is. It's an interference pattern. It's caused by one tone or one bit of energy intersecting with another bit of energy. So, does that make it? So anyway, the way that works with light. Now let's talk about the way that works with light. Let's draw this back out here. The way that works with light, if you want to make a hologram, the way you set that up in a room, you have a table, and this is the basic hologram. This is not what's on your credit card. What's on your credit card is something else. But there's a kind of a simpler and more pure form of a hologram, which is the thing that was kind of originally found. And the way you do that, the way you make those, is you have a laser. And the thing about a laser is a laser sends out what is called coherent light. Coherent light. And what that means is that, we see the waves, and we know that light travels in waves too, and that there are different frequencies, and the different frequencies relate to different colors. Well, the laser sends out a beam that is a pure color. It's all one frequency. And not only are not only is it all one frequency, but all those waves are kind of marching in step at the same time. They're all going this way. None of them are going this way. It's like a polarizer. It's what polarizing glasses do outside. They cut down on the waves that are going this way, and they'll just let waves come in, from one particular way, and it cuts down the glare. So you get a clearer picture of what's out there. Well, same thing happens with a laser, except that is just highly polarized, a very specific frequency, and that's where the power comes from in a laser. And it's coming in a very tight little beam. It's not going to, you can send that little beam out to the moon and back, and it's going to stay a little beam. It's not going to, if you send a flashlight out there, as it goes out, it's going to diverge, and so it's going to dissipate. But with a laser, that's not the case. So you have this, we'll call it, for all intents and purposes, pure light. We have a very pure light that's coming out of the laser. So what happens is you set up this table, and it has to be a very solid table. They make them out of sand, and they float them on a cushion of air, so that if a truck goes by, there's no vibrations in the table. So it's a very kind of dead, kind of dead to the rest of the world, really, is what it is, as much as they can make it. So it's a very solid table, weighs a lot, no vibrations, because any vibrations at all would kind of disrupt the pattern. But what happens is you set up, there's a laser here. They set up a mirror. It's kind of half silver that'll let some of the light through and some of it not. There's a lens. Then there's another little mirror which is fully silver, and another little lens. And out here somewhere you put like let's say a little object. Say we got a model car or something. Okay. So that's just kind of sitting out here in the air on the table. And then in here we put a piece of film, and there's no camera or anything. It just sits out in the middle of the air. It just sits out on a little holder out in the air. And so what happens is the light comes out of this laser. Some of it goes through, and this is still coherent light. It goes out of this. It's diverged a little bit, and it goes and hits our model. Some of it comes over here, goes through here, diverges again, and this hits the back of the film. And this light bounces off here. Now it's no longer coherent light because it's going all over the place. It's reflected, like that sound reflected off the wall. And so the thing that comes up, what ends up whenever you process this film that's just sitting out in midair, is just a little interference pattern. It's just a little pattern. You don't see a picture at all. You just see the interference pattern on the film, and it looks kind of like a moire pattern that we from years ago. You look at things and make your eyes go crazy. But that's what that looks like for all the world. But if you shine the laser, if you shine this light back through that, then all of a sudden you have something that is a truly three-dimensional picture. It sits there. If you turn it this way, now you see the back of the car. You turn it this way, now you see the front, the top, the bottom. And if you were to take a picture of that, with a camera, the front part of it here, the closest part to you, would focus in a different place than something that was, say, on the middle of the top further back. So it's a true 3D image that's reconstructed whenever you shine this coherent light back through it. And another interesting thing about that, and you know, there's lots of repercussions, lots of things that we that you can talk about. But one of the interesting things about this little hologram is that all of the information to reconstruct the entire hologram is in every piece of that little piece of film. So if you take and cut out a little corner of that piece of film and move it through this laser light, you'll see, you know, this part of the car and this part of the car and this part of the car. To me, it's just an amazing thing, you know. But I mean, we can relate that to all sorts of things. I'll just tell you about that. But so anyway, okay. So now that's how that works as far as light. We're kind of seeing all the relationships here. Am I making this too hard, or is it you know? I know this is scary science. You know, this is you know. One of the things here I forgot to mention. I was going to put up the famous formula. You know, yes, that's the famous formula. Yeah, when we get to touch now, we've done sight and sound and how all of that stuff works with the hologram. When we get to touch now, all of a sudden we know we've talked about you know, everything just going back to energy and back to vibrations. Calvin always said everything is vibrations, everything is vibrations. You know, but it's true. But you know, everything changed whenever Einstein figured this little bit out. And the big deal about that equation, E equals mc squared. E, the energy something a particle possesses, equals its mass times the speed of light squared. The speed of light, again, is that one thing that in our universe, in our world, that's the one thing that everybody can agree on. You know, time. You know, there's a paradox in science called a twins paradox, where if there's a set of twins and one of them stays on Earth and one of them gets in a rocket ship and goes away at near the speed of light for 10 years or so and comes back, well, the math says that the twin that stayed on Earth is going to be older than the twin that went out into space. And as a matter of fact, you know, whenever we got to where we could launch rockets and do all of that thing, they used little atomic clocks and they sent them out in different directions. And they found, well, actually, yes, time changes according to your motion through our world here. So time is not something we can count on. The only thing we can count on is the same for all observers, no matter how fast they're going or what direction they're going or anything. The one thing we can count on is that 186,000 miles per second. So Einstein used that as a constant, the c squared, that's the speed of light squared. And then he redefined matter here in terms of energy, saying basically that matter and energy are the same thing. You know, that's where we get back to our little drawing here. So how does that happen? You know, this is where it starts to get metaphysical again. You know, because we get back into the beginning of everything. You know, what was the beginning of everything? It was the Big Bang. You know, it was this big blast of energy, and from that, everything came. And we can, you know, of the parts that we have talked about with a hologram, you know, we've had kind of the reference wave, which would be our laser light, or the sound coming out of the speakers. We had that reference signal, you know, with matter. In those, we've had a reference signal, and then we've had kind of a reflected signal. We've had two versions of that signal, you know. So with matter, we kind of have to look at that and say, well, what are the corresponding parts here? You know, what are we, you know, how, if we know we have particles here, and it seems to be working in exactly the same way that the little sound thing did, you know? These little things crop up. Well, what is that, you know, where's our reference signal in this process, you know? And to me, you know, I may be crazy, but to me, you know, that's kind of where we start to talk about God, because somewhere in here there's a pure signal that's a reference signal, and you know, there's a reflected signal. So somewhere in there we're getting this little pattern, you know, and those are the only two places that I can see where we do that, you know. But when we get, here's another interesting thing now about particles. And this is kind of where they started figuring out that they were waves rather than like BBs. You know, they would take an electron gun, like the thing that was in the back of your old TV set. You know, when we had a TV, when we all had screens, you know, the big tubes and everything. You know, there are little electron guns in there, and they just shoot out a steady stream of electrons that just hit a phosphorus screen. That screen is covered with phosphorus, and where it hits that, they light up. You know, so they were doing that. They were taking particles and just shooting them kind of one at a time, like BBs, at a little slit, because they were wanting to see how they deflected and everything going through the slit. And so they would put up the slit, they would shoot these particles through there, and it would show a pattern on that phosphorus screen back there. And they thought, okay, and it's about what you would expect, like you were sitting there plinking at it with a BB gun. And so they put up two slits, because they wanted to see which slit the particle might choose to go through. Well, the particle would go through both slits. It wouldn't go through just one slit, it would go through both slits. And so they said, oh, that's interesting. It must be, it's not a particle, it's a wave. You know? And so then they start to go, oh, okay, there's kind of where our reference wave is. It's not base level energy. And there is a base level of energy in the universe. There's a thing they call 0 point or ground state, where there's no place in the universe where energy is not. You know, but that lowest point where that is, you know, they call that ground state, and physicists are still writing formulas and everything, trying to get away, trying to hide that ground state, you know, because it's problematic for them. But anyway, whenever you look at this thing, to me that kind of becomes obvious, you know, when you think about this, you know, this double slit thing in the observer. Now all of a sudden the thing, that reference wave, kind of becomes not energy, but just consciousness. You know, all of a sudden that's consciousness. You know, and the interesting thing about that is consciousness now is not constrained by this little barrier that we set up here. Consciousness is not constrained by that. Now all of a sudden, you know, it opens up this little area in here to us, you know, because there's no mass to consciousness. You know, it doesn't have to get pushed faster than the speed of light. So now all of a sudden, you know, you've opened up basically a whole new world. And the crazy thing about that, is when you start bringing consciousness into it, you bring a whole bunch of other stuff into it. Because now all of a sudden, consciousness, as we know it, has other aspects other than color, and that's what it kind of relates to color. But we got intelligence, you know, and we got intelligence. I'm going to misspell intelligence. Oh, can somebody help me with this? However it is. Anyway, you've got intelligence and
just like smartness.
I don't know what everybody does. I just lost my place. Anyway, you have thought, you have intelligence, and you have personality in there. You know, now all of a sudden, consciousness adds a whole different dimension to this whole process. You know, and so we have to, in a sense, start thinking about, you know, we go back to now just think about ourselves in terms of all of this stuff that we've talked about and how we manifest in this world and how whatever it is we're experiencing, what in the dickens is it that we're experiencing? I mean, it's a crazy world. To me, it's an odd world because, you know, you come in, you live, you die, you eat. That's an odd thing to me. You have to eat something, you have to consume something that was alive in order to subsist. I mean, does that make sense to everybody? I mean, does that seem odd to somebody besides me? But, you know, so anyway, the nature of what we're experiencing to me is just kind of a crazy thing. And I start to try and relate that, you know, to me because, you know, it kind of comes down to the fact that, you know, if you really want to know what reality is, you have to do like Descartes did, you know, and back up and back up and back up until you can find the one thing that you're sure of, you know, and really, we've taken away all of this stuff, you know, we've taken away everything else, and the only thing we can really be sure of is that I'm here. You know, I'm not sure about you guys. I may have made you up, and if I did, I apologize. Sorry. But anyway, you know, I think therefore I am. That was Descartes' big. He gave us a couple of things. One of them was kind of scientific method, which kind of sent us off on a couple of different rabbit trails. But the good one was I think therefore I am. You know, and so we kind of have to go back to that. And I start to wonder what this thing is, and I realize it's, and we all know about this because we're metaphysical folks, you know, and this is not surprising to us that we're an energy body. We are some configuration of some combination of all of this energy stuff and all of this consciousness stuff. Somehow or another, we're configured as an energy body. And the interesting thing about that, now let's get back to, how are we running the time, right? Am I taking too much time? Okay. Anyway, the interesting thing about that, let me put a couple of words up here for you. Consonance and dissonance. Let's use those terms for a second, because when we're talking about our waves again, we're back to our waves again. We're talking about the interaction of all of these things. One of the other things that happens with waves, because waves interact, is that, you know, other waves like this that are in the same space as these, they interact. You know, so what happens is it doesn't necessarily, depending upon how this works, you know, what it does is it changes the character of this pure sound right here. It changes that character. And so, you know, the simple forms of waves, you have the sine wave. You can add a few. Here's our sine wave again. That's not our sine wave. There's our sine wave. But again, all the same note, but a different character. And what's happening there is that these other energies from other frequencies are moving in there, and it's changing the shape of this wave. And there are waves that they call sawtooth waves, which are like this. You know, there are waves which they call square waves, which are kind of like this. And so what happens with that is that these other waves, these harmonics, they call these higher harmonics, working with this, and they're working through that principle that we all know, and we talk about. We use the term in a lot of different ways. It's a resonance. We use that term in a lot of different ways. And let me get my guitar. I'll show you. You know, one way that I get to see it is when it's with my guitar. You know, I can play a note. This note here, and if I play that note, you might be kind of soft, you can't hear it. But oh, wait a minute. Oh, wait a minute. Let me put this on there. This will make it work. But if I play that note, it's kind of. If I play this note and I dampen it, there's still sound coming on. It's a resonance. It's kind of this note. The energy from this note has caused this note here, which is kind of a mathematical relationship to it. It's just caused this other note to vibrate. And that's called it resonates with. It's a resonance is what that's set up. And some things are consonants, cause things to resonate. You know, that's a consonant sound. That's a pretty sound. You know, we have dissonant sounds. That's a dissonant sound. You know, that's not a pretty sound. You know, so that's kind of what's going on here. Is that these things with different mathematical relationships, and it's causing this pure sound to deviate from its pure soundness, from its purity. Okay, and we can relate that. I relate that in a lot of ways to us, the people. You know, I can see a way to do that, and I think in terms of, you know, I think about myself, and I think about being busy and going through my day, and I'm just kind of crazy with everything that I'm trying to do, and I realize that if I could see my energy body when I'm going through my day like that, you know, when I'm a little bit frazzled and everything, I figure my energy is going to kind of look, you know, this is going to be my energy right here, you know. And I think if I really wanted to move towards, if I wanted to move my energy towards this coherent state, let's call it, or towards this consonant state from my dissonant state, that, you know, what I would really like for it to look like is maybe like, you know, maybe like this or something, you know, with, that would be nice if I could, you know, just be like that. And it turns out, you know, we all know this, but you can move towards that. You can move towards that through your focus, you know, through just where you place your attention. Our consciousness is something. It's not nothing. You know, we've seen that there is power just in thoughts are things. Meditation does that. And when we get the guitar again, here's another interesting thing. I love this little deal, but you know, I can play my guitar here, but I play that note. If I hit that note, that's actually a much purer sounding note. I love the sound of that note, you know, it just kind of rings. And the thing about it is, I'm not having to press the string down to make that note. I'm just touching it. I just touch it and let it go. You know? And what's happening there, that to me is kind of like a transcendent sound. You know, that's like beyond intention. You know, you kind of just sit there and go, oh. You know, and so I love that little sound. And what's happening with that is, I'll draw you one more little diagram here, is that the string is vibrating, you know. Oh, let me draw that better. The string is vibrating. I'll draw it here. Oh, come on. I'll get it right in a second. Yeah, let's draw it like this. The string is vibrating. And anyway, assume that this is all of these things are even. But what's happening is these points right here are kind of still points in the vibration of the string. You know, it's not vibrating as much there as it is a little bit further down in the string, where it's going wah 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 wah, and then down here it's going woo woo. So that's because it kind of replicates the shape of the wave. So right here is kind of a little still point in the vibration of the string. And I relate that, you know, and when you kind of hit it at that still point and let it go, it's just kind of transcendent. And so I loved reading Eckhart Tolle. Talks about finding that still point, you know, and that's kind of what we're doing energy-wise with ourselves. Is whenever we get to this still point, when we can meditate and come to a still point, all of a sudden we can kind of move from this state to this state, and our experience becomes somewhat transcendent. You know, and so I got one other little thing I just want to mention to you.
You got 10 minutes.
Okay. Well, I may be done, Calvin. But anyway, an interesting thing. Well, maybe I can give you two kind of interesting things. But one, first interesting thing, you know, is to me, you know, I think about the way we come into the world, and you know, our ego and all these different things, you know, and you know, I know, Course in Miracles, we have a great teacher among us here today, Gene, but A Course in Miracles, you know, talks about our ego and losing our ego and becoming, basically what we're doing in that process, you know, of losing our ego, is moving into this coherent state. That's really what we're trying to do in that, you know. But while we're in this world, we do kind of end up having our ego. And so the way that I kind of picture that is that, you know, we each kind of have a character, like this sound that comes here. We each kind of, if you see the world as a symphony, you know, we each come in with an instrument, you know, and some of us come with a trumpet, and some of us come with a violin, and some of us come with a drum, and some of us come with a kazoo, you know. And the thing about, you know, the thing I love about a kazoo is it kind of annoys everybody else. But the person that plays it, you know, it's just a joyful thing. You cannot do a kazoo and not be happy. I don't believe it, you know. And I also, you know, thought, well, every automobile in America ought to come equipped with a kazoo, so that you can stick it in your mouth, you know, wherever somebody cuts in front of you, you know, and instead of yelling at them, you go, you know, and who can be mad, you know, after you do that? But anyway, so I think, you know, a lot of what we're doing in this world, in some point, I mean, an interesting thing about this too is that, you know, with your ego, there are times, you know, in this world, we could all be level, we could all, you know, but at times in the symphony of the world, you know, it seems like maybe it's time for the violin player to stand up and play by himself. You know, you know, so, and I think our ego needs to recognize when we're kind of in our purpose, rather than when we're just doing, you know, just flailing about in the world. If we can kind of discover our purpose, then we kind of know our instrument, you know, and we can kind of walk through the world. And one more interesting thing, whenever this happens, let me give you this little deal here. I can keep going, but I'll do this one little deal here. Think about this. A bar of iron, you know, it's just a bar of iron, and all these little particles in here kind of going all over the place. But this bar of iron can also, you can order this so that the particles in this become more coherent. And when that happens, the bar becomes magnetized. You know? And when we kind of move into this state, I think of it as that's kind of what we're doing with this. We're kind of in a sense becoming magnetized. And the interesting thing about this, now this bar is not just this bar, it's interacting in a different way with the world around it. It's interacting in a totally different way, and it can be a very useful way. But anyway, Just wanted to do that. And then the other thing is, I just wanted to pass these around so that everybody can have a kazoo. I think I got enough. We might not have enough for everybody, but I brought everybody a kazoo just for that.
I have over 100 of them in my house.
Oh, can I add your collection? Anyway, I think that's kind of got about my time for